Imagine you finally found your dream home. You apply for a mortgage, hit submit, and within seconds, denied. A computer just locked you out of a major life milestone. When a machine makes a choice that big, it naturally raises some hard questions. How do you know the real reason behind the rejection? And how can you be certain the software avoided using factors like your age or your neighborhood to count you out? Accepting a computer's decision when you can't see under the hood is a major risk. To build real trust, users and regulators are now requiring companies to provide concrete, documented proof that their technology is acting fairly. The solution is a universal safety code for technology, ISO 42001. It's a master playbook for building and supervising AI. Like a physical blueprint identifies load-bearing walls, this digital blueprint maps out structural supports to protect people from unexpected errors. This framework relies on a library of documented evidence. It moves the responsibility away from the good intentions of a single programmer and puts it into a system of verifiable rules. When we apply this kind of structure to software, we turn an unpredictable risk into a tool that the public can actually monitor and control. To see how this works, let's go back to that bank. We can build a much safer loan approval system by supporting it with 6 mandatory pillars of evidence. The first pillar is transparency. You have a right to know why you are rejected. The bank proves this with an explainability log, essentially a clear answer key that shows exactly which pieces of your data led to the computer's final no. Second is reliability. The AI must calculate risk accurately for every applicant every time. This is proven through performance metrics, which are like a report card showing how the machine handled thousands of practice tests. Third is ethical AI. The system must be designed to avoid discriminating against specific groups of people. The bank verifies this through fairness checkups, audits that look for any signs of accidental bias in the results. Fourth is adaptability. Since the economy changes, the AI must be able to learn. We check this by looking at the retraining schedule, a calendar that proves the bank is teaching the AI fresh information on a regular basis. Fifth is teamwork, or how well this AI talks to the bank's other computers. We confirm this with an integration guide, which is a set of instructions that ensures different software programs can share data without crashing. The final pillar is security. This ensures that hackers can't change the AI's rules or steal your private info. To prove it safe, auditors check the access logs, a digital sign-in sheet that shows every single person who touched the system. The golden rule for these systems is simple. If a company hasn't written down exactly how these 6 pillars work, that AI isn't ready to be trusted with real-world decisions. Even with these pillars, we have to look for cracks. For example, what if the AI notices a mathematical pattern in certain zip codes and begins rejecting an entire neighborhood by mistake? That's a serious ethical failure. To spot these threats before the public is ever affected, companies use a risk management process. It's a formal way of hunting for what could go wrong before it actually does. The bank records the threat in a register, studies how it might hurt families in those neighborhoods, and then writes new fairness rules directly into the code to filter out that bias. This shows that ethical technology isn't a happy accident. It is the result of a company being forced to look at its own risks and engineer a specific solution to fix them. A physical building stays the same once the concrete dries, but AI is different. It is constantly learning and taking in new data. Because it's always changing, it needs a permanent maintenance crew to stay safe. This circular loop is the engine of maintenance, the PDCA cycle. In plan, the bank sets safety goals. In do, controls go into action. During check, dashboards monitor for fair choices. Finally, in adjust, problems are traced to their source to retrain the model. Because this cycle never stops, the system is always getting better. It uses a constant loop of feedback to force itself to stay accurate and safe over the long term. The next time a computer makes a big decision, remember the rigid rules and structures supposed to be happening behind the scenes. Every AI system is a complex piece of machinery. Like a high-performance engine, it requires a strict, documented management plan to keep it running safely. When we insist on clear principles, deep documentation, and constant checks, we transform artificial intelligence into a reliable tool that we can finally, confidently trust.